Hello everyone, my name is Sachin Sharma and I work as a cloud network specialist in Oracle since 5 years now, and I'm in cloud networking for more than 8 years in my IT career. For today's session, it is on OCI Network Firewall, and we'll be talking about the next generation firewall which is introduced by OCI, Oracle Cloud Infrastructure, and it is built using industry-leading Palo Alto Networks next generation firewall. This firewall provides you the features like IDS, IPS, and TLS inspection, and SSL inspection for the traffic which is coming in and going out of your firewall. It is having a feature of having a URL filtering also. I'll be talking about these features in details in my upcoming slides. So, what are the benefits of having a cloud network firewall as OCI? So, it is a cloud native scalable native firewall, and it is managed by OCI. It is a best service, so customers don't have to actually look for the management consoles like they have in their next generation firewalls on OCI. By default, it is highly available. That means if you are going to have a OCI network firewall spinned up on your OCI console, you don't have to look for high availability, as by default it is highly available network firewall. It is integrated with OCI. So yes, as I've told you, it is integrated with OCI platform, and it is integrated with logging and metric services of OCI. So many of our customers have asked how to see the logs for OCI network firewall. So yes, it is already integrated with our OCI logging and metric services. It is having a layered defense, and yes, it is having IPS and IDS inbuilt, which will be used for advanced threat protection, which will definitely meet your compliance goals. So looking forward for the next slide now. What are the features which our OCI network firewall is having? So you can create your own stateful rules for the traffic which is hitting the network firewall for your applications on OCI, which you can provide IDS and IPS for them. URL and FQDN filtering you can do on OCI firewall with a very flexible way of creating policy for those users or for that particular traffic. And yes, you can protect your customer applications, you can protect your anything which is running on OCI VCNs, virtual cloud networks over here. So if I just move to the next slide, what it says, I'll just try to annotate it and take spotlight. Okay. So it says stateful firewall rules. So when you look at the right side of this slide, it will say create network firewall policy. So when you are creating a network firewall on OCI, you need to first create a network firewall policy, and that network firewall policy will be attached to a network firewall. So what you have in a network firewall policy? So these are the 5 things which you'll be having when you create a network firewall policy. So the first thing which you can see here is basic information, that is your firewall name and all, sorry, policy name and all. Then comes lists. So there are 3 types of lists when it comes to the network firewall policy. First list is application list, where you can define your applications, ports and all, such as for RDP you will define 3389, for SSH you will define port number 22. It will be in a range. If it is a single port, it should be in written like that. It is in a range. That is like for RDP it should be 3389-3389. And then come IP address list. So in these IP address lists, you can define the IP addresses which you need to put into your security rules or decryption rules. And then comes your URL and FQDN list. So in URL and FQDN list, you can define the URLs you want to log and allow for the users on OCI or for the remote users who are going to access your applications from either internet, from on-premises to OCI over DRG and internet gateway. Then comes the rules, that is stateful firewall rules over here. There are two types of rules. One is decryption rules and second one is security rules. So these decryption rules actually which will be created for your decryption profile which you have created. What is decryption profile? This decryption profile will be used for your incoming and outgoing traffic for HTTPS to just to decrypt it and see if the traffic is legitimate or not, and then send it to the destination server. So for that, you will be creating a decryption rule with the list which you have already created in the second point. First thing, when the traffic hits on OCI Network Firewall, it will check the decryption rules. And when it doesn't find the match on decryption rule, it will go to the security rules. These security rules are stateful rules, and these are 5-tuple stateful rules, that is source IP, destination IP, source port, destination port, and protocol. That is known as 5-tuple. That is a 5-tuple information, and it will do a hash of it, and then it will create this. It will check the particular traffic which is hitting the firewall. It will be used for both IPv4 and IPv6, and it says rules can be enforced in a customer-defined priority order across multiple virtual networks. That is, it will be checked on the priority which will be defining while creating the security rules. Then comes the stateful firewall takes into the account the context of traffic flows for more granular policy enforcement. So definitely it is more granular. So this is known as stateful firewall rules, which works on 5-tuple hashing, and it is working for both IPv4 and IPv6 traffic. I've already told you what is the list. I will show you in our demo how these lists can be created. Then coming to the next slide. Here, URL and FQDN filtering. So this URL list will come into the list section only. That is the second one, and why it is very much important over here. So if you want to do a SSL inspection for your traffic which is hitting your firewall, either which is going out of OCI or it is coming from remote users to OCI and hitting the firewall, you need to do a SSL inspection of the particular traffic and decrypt it and see if the traffic is legitimate or not, and then send it to the destination server. Yes, you can do it without firewall by creating your URL list into the list section. So suppose in my demo I have created some star.oracle.com that my users will be able to access only star.oracle.com to the internet, and everything else will be denied. So in such a case, if you want your users to only access a particular set of URLs and nothing else from OCI to outside world, or from outside world to OCI, you can create those URLs here, and you can define the wildcard also over here. It is very flexible and it is very easy, and you can do it by simple clicks on OCI console. And then comes now the other feature which we are having on OCI Network Firewall, as it is followed by networks right behind. So it is using intrusion detection and prevention system by Palo Alto Networks threat analysis engine. Okay, and you don't have to do anything. It will identify new threat signatures, have some detection mechanisms which will be updated by automatically on our network firewall, and the signatures will be updated automatically on our network on a regular basis when Palo Alto does it. It will help detect IDS and block IPS. Once IDS is detected, it will block that particular IPS for you, and you can define that particular IDS and IPS for a particular traffic when you create the security rules. I'll be showing you that too. And the most non-exploits like malware, malicious URLs, spyware, and yes, C2 for sure, command and control attacks. When it comes to the next slide, so our as I've already told you, that OCI Network Firewall is integrated with OCI logging and analytics services. So the metrics, the network firewall metrics, it will help monitor the health, capacity, and performance of firewall policies which you have created and the resources. Definitely, you can define the alarms and notifications which can be configured. So when the metrics meet the alarm specified, it will trigger it to the users over there. Network firewall logs, definitely I'm going to show you how these network firewall logs looks like and where you can see the actual traffic hitting the network firewall while coming in or going out of it. Logging analytics will provide you the analytics over here. So it is integrated with logging, monitoring, and analytics, and it is very easy and user-friendly over here on how to see the logs, how to use the monitoring and analytics services with OCI Network Firewall. Then comes OCI Network Firewall key use cases. So we have been working with OCI Network Firewall since it is LA. We have seen customers where they could use OCI Network Firewall. The customers who were already using next generation firewalls like Palo Alto or some other marketplace images, they can still use our OCI Network Firewall in the same manner to protect their traffic, to monitor their traffic in the same manner what OCI marketplace images are doing at present. So the first use case for this is for internet facing application, and that will be my first demo too over here. So if an application is internet facing, you can create the network firewall onto that which will protect against known vulnerabilities until you have time to do a patch or update. And the best example is for CV 20175638 for your Apache struts. And the second use case which comes over here is outbound, protect against exfiltration. So outbound, for your outbound connectivity, if your users on OCI want to connect to the outside world from any of the gateways like internet gateway, you can say like dynamic routing gateway, it will protect, you can protect your data which is going out of OCI from the resources in OCI through OCI Network Firewall. These are the examples, perfect examples of securing and monitoring your north-south traffic. This is going out of OCI. And then comes east-west traffic. So the first two use cases are for north-south. That is the traffic which is going out of OCI. And the third use case and the most useful case when it comes to monitor the traffic within OCI, within virtual cloud networks of OCI, within different subnets in OCI VCNs. So that traffic is known as east-west traffic, and it says east-west between VCNs or subnets. So I'll be taking these use cases in the form of a demo, and let us see what our next slide says. Yeah, it shows us the demo slide only. And I will be stopping my video because I'm going to showcase the demo now. Okay. So the first demo which we are going to showcase over here is north-south internet traffic flow via internet gateway through OCI Network Firewall in a secured VCN. So here you can see that is secured public subnet over here. And you are having a firewall subnet, and yes, your firewall should be in a different subnet where your resources are. It should be in different subnet. Okay, it can be in the same VCN but different subnet. So here I am having a firewall subnet. So here my OCI network firewall is here, and it is protecting the traffic for my application or my virtual machine, which is in my public subnet over here. So if you can see over here, the incoming traffic from the internet, it will hit the internet gateway. From internet gateway will be having a route to go to my firewall for anything which is coming for 10.10.0.0/24. It will hit the firewall. Firewall will check the decryption rules which you have created, the decryption profile which you have created for the incoming traffic, and then it will send or the security rules which you have created for the particular virtual machine. And then if the traffic matches, it will send it to the virtual machine. If the traffic doesn't match, it will drop that traffic over there itself. And then virtual machine from here in the right hand side the backgoing traffic from the virtual machine. It will be sending every traffic that is a default route with a default route to my network firewall. My network firewall will take it to my destination, that is my subnet route table, to the internet gateway, and internet gateway will take it to the internet source from where the traffic is coming to my virtual machine. Now let us see over here in the demo section that how does it look like. The demo. I'll share my screen over here and let us see how. Okay, so I'm using network visualizer over here. The people who doesn't know where we can find network visualizer is, so you can find the network visualizer in our network command center. We are having some more other tools for troubleshooting, such as network path analyzer. You can actually utilize to troubleshoot your small networking issues, connectivity issues. And this is network visualizer, where you can actually see the network which you have built for your customers. So here, what I have done is, so this is my hub network. So if you can see my pointer, this is my hub network. This hub network is having an internet gateway. Having an internet gateway, net gateway, and service gateway is also there. I'll talk it about later. For this first use case, which is for which the traffic is coming from the internet, I have an internet gateway over here. So this VCN, firewall network VCN, I'll be talking about DRG spoke VCNs afterwards. For first use case, I'll take this VCN. And for this VCN, if I just go for view additional resource details, I can see 3 subnets over here. So for my first demo, I'll be using my firewall subnet and public subnet. I have deployed my OCI Network Firewall in my firewall subnet. When you deploy a OCI Network Firewall, it will take the IP from the subnet itself. So it has taken the IP from 192.168.1.6/24. If you want to assign an IP of choice from the subnet, which is free at that time, you can do that also while creating the network firewall. I have 2 machines in my public subnet over here. One is my Windows machine and the second one is my Linux machine. They both are internet accessible. Okay, the first thing is, from the security perspective, you should not have your machines directly exposed to the internet. Okay, whether it is coming from network firewall, whether it is coming from OCI web, because it is not a good practice. It should be behind a Western server or behind a load balancer or something like that. But for this demo, it is a direct demo, so I've created 2 machines. One is Windows, the second one is Linux machine in my public subnet, and I'm going to access my Windows machine over RDP, that is 3389, and I'm going to access my Linux machine over SSH connection, that is port number 22. So let us see my firewall subnet and what routes I am having onto my firewall subnet. I will take you from the network visualizer to my virtual cloud networks now. On this virtual cloud network, in my firewall subnet, I am having, in this VCN, I am having an internet gateway. And my address range is 192.168.0.0/16. And my subnet address range, which I'm trying to reach from internet, is 192.168.2.0/20. So as per the diagram which I've shared it with you, as per the diagram over here, on my internet gateway, I should be having a route for my firewall IP for my subnet address range to go to the firewall. So let us see whether I can see it over here or not. So when I just go to firewall subnet over here, check the route table which is attached to it. Leave the other routes. These other routes are for the following demos which I'm going to show you. But yes, this is the route for my firewall. It says that whatever traffic is coming from on the firewall and destined for the internet, go to the internet gateway. This is the second route. Now I'll go for the internet gateway first route. The traffic, when it comes for my public subnet, okay, this route table comes into the picture, which is my internet table. It says 192.168.0.0/16. It is my VCN address range. You can define the subnet address range also over here. Okay, or you can define /32 IPs also if it is a single machine over here. So I have defined the VCN address range. I could have defined 192.168.3.0/24. That is my public subnet range over here to go to 192.168.1.181. What is this 192.168.1.181? This is my firewall. This is my firewall. And this firewall you can see into the security sections. Identity and security, it comes into firewalls, then you go to network firewalls and create it. My network firewall is having 192.168.1.181 and I am routing all my traffic from the internet to the network firewall for my public subnets. So when it comes over here, this is my internet gateway route table. And what is my public subnet route table? When it comes to public subnet, the outbound traffic, it says where the traffic is defined for the internet default route, send it again to the network firewall. When it goes to the network firewall, again I have shown you that this is my firewall route table and the traffic will go to the internet gateway. So basically I've shown you the route tables on the OCI console, which I was showing you in my PPT over here. From here to here, firewall, from firewall to virtual machine, from virtual machine again to the firewall, and from firewall to the internet. What it does is, it for any traffic which is coming from a compute instances, it is going to the firewall. Okay. Now what instances I am having over here? So I am having one Linux public machine over here, which is in 2.subnet. That is my public subnet. I am having a Windows machine which is still in 2.subnet. That is my public subnet. The rules which, okay, now I'll show you how these rules look like on network firewall. So when I click on network firewalls, when I created the network firewall, a policy you would have already created for your network firewall. So when I've created this network firewall, I have attached that policy, that is copy of new decryption firewall policy. I'll show you how this policy looks like. In firewall section, there are two options. That is network firewalls and the second one is network firewall policy. So first I have created the network firewall policy. So how this policy looks like, I was showing you there will be list section and you can create decryption rules, you can create your decryption profiles for your inbound traffic or inbound SSL inspection and for the outbound traffic for as a SSL forward proxy. How you can do that? You can do that by creating a policy. Let us see how this policy looks like. So first comes is rules, but when you create the firewall policy, the first thing which you'll be defining is lists. Okay. So these are the lists. So first is the application list. So what I have done in the application list is I have created a RDP application list and you can see what port I have defined over here. So I've told you it is by range. So you cannot define a single port like 3389. It should be a range. So if you want to define a single port only, you need to define it like 3389-3389. So I have defined for 3389-3389 for my RDP, for my SSH, for my Linux machine, I have defined it for 22-22. The URL list I am not going to talk about at present. Then comes the IP address list. For my IP address list, I have created my IP addresses and put it into my Hub Linux machine and Hub Windows machine. I have put the IP over there, their IP is over there. Once I've created this IP address list and my application list, right, I need to create the rules out of them. I need to create the rules to allow RDP port number 3389 into my Hub Windows machine and port number 22 onto my Hub Linux machine. So how I've done that, I've created rules for that. So when I go to rules over here, there are two types of decryption rules and security rules. Again, I'm saying for SSL inspection, you need to create the decryption rules for your traffic heading to your OCI network firewall. For this, I have created security rules because it is for my 3389 and port number 22. And when I've gone to security rules over here, I've created some good amount of rules, that is 11 rules over here. These rules, it says allow RDP Windows Hub machine. Allow RDP Windows machine. When I click on this, so it says for the source any IP address, because any IP address by default is any IP address, and I have not created a source IP address for my machine, but still you can create, or customer can create for if they are having any public IP address ranges which are going to communicate with OCI. So here I am going to create any IP address. Destination is my hub Windows machine IP, which I have put in the IP address list. Application, which I have put in the application list, that is my RDP, and any URL. Because it is layer 4, I need to give any URL over here. So what this security rule, when the traffic is hitting onto this network firewall, it is checking this rule, and it comes to this rule and it matches, and it will allow it for port number 338. The same thing I have done for my Linux machine. Allow SSH hub Linux. So it says any IP address, and if my destination is hub Linux machine, over here application, okay, it is saying SSH. You just look at SSH, and I have attached one more application over here, TCP/IP443, that is for our URL and activity filtering I will be talking after. So SSH and any URL. So, and here in URLs for TCP/IP443, you can provide your URLs also. For layer 4, there is no need to provide URL. It needs to be any URL. So for allow SSH hub Linux and allow RDP Windows machine, let us see whether I am able to connect to these Windows machine over here and Linux machine from OCI Network Firewall. So let us just see. I am going to RDP to this machine and just see obviously over here, and I'll take this over here. Okay, this RDP. Here, and this is my IP, and I'll connect it. And yes, I am able to take RDP. I am going to take RDP into this machine because I'm going to show you where you can actually see in the log section that yes, I am going to network firewall, but not directly on this Windows machine. So I will just put my password over here. And yes, I am able to take the RDP to this machine. In the same way, am I able to do the SSH to my Linux machine through putty? I will do SSH and just put over here. Open my keys. Okay, and open. From here, I am able to do SSH to my Linux machine. That means my network firewall rules are working well. I am able to access it. And what is my IP? Let us see what is my IP. And this is my IP. We'll check in the logs afterwards whether this is showing onto the logs for my OCI network firewall. Now this is my first demo which I've just completed for my north-south internet traffic flow through internet gateway for my public applications. And I believe there are many questions which should be coming. Yes. So this is my first use case or first demo which I have provided over here. Now going to the second demo, that is east-west traffic. So I will elaborate this use case into two parts. That is the first one which I am showing it over here, and I will be showing you a third demo when my hub and spoke architecture is connected over a DRG. So there is a DRG connect which is connected to my hub and spoke, and I am inspecting the traffic for my hub and spoke subnets from OCI Network Firewall. But that is the third use case. Let us concentrate on this use case, that is the east-west subnet to subnet communication when it is in the same VCN. So suppose here my subnet A virtual machine wants to talk with my subnet B virtual machine, and I want this communication to be monitored by my firewall. That is my east-west traffic within OCI. So yes, this can be done, and the traffic will definitely go through OCI Network Firewall. So this is the route which is very easy to attain over here, and the traffic is destined for my subnet B. It needs to go to my OCI Network Firewall IP. When the traffic is destined for subnet A, it needs to be destined to my OCI Network Firewall IP. It is same from subnet A to subnet B, and it is same from subnet B to subnet A. So let us see in the demo. The demo it will be more clear. So again, I'll go to my network visualizer. Here in my network visualizer, now I am having two subnets, that is this one and this one. I want to communicate from this subnet to this subnet from firewall subnet. So I want to monitor all the traffic going from this subnet to this subnet from this subnet. So I've created such kind of routing. I've shown you what routing needs to be created. So here on my firewall, not on my firewall network, on my subnet, on my public subnet, on my, just take it as private subnet A, that is 192.168.2.0, from 2.0 to 3.0. When I go from the firewall. This is the route table. When I go to 192.168.3.0, it should be going to the firewall. And when I'm coming from 3.3 to 2.2, that is private subnet to this subnet 2.0, it should be having the same route over there. So let us see in the route table. And yes, we are having the route over here for private IP 192.168.1.181. So now every traffic should go from my OCI network firewall, and let us just see that in the demo. So what we need to see over here, first we'll go to the policy again. Let us see what policy we have created. So here for my hub to hub communication, that is hub subnet to hub subnet communication. So it says, okay, it says ICMP private Linux hub. This is one rule which I have created. When I click onto this, it says if the traffic is initiated by my hub Linux machine or hub Windows machine to my only private Linux hub, it is only private. I have not added Windows. Okay, that will check. So ICMP, allowed ICMP ping for that. Okay, for any URL, because it is layer 3 actually, ICMP. And the second rule which I have created for my Windows machine is the traffic is initiated from my hub Windows machine, which I have already logged into, and destined for my private Windows, allow RDP, but no ICMP ping. So we'll see whether this particular rule over here is working well or not, and whether the traffic is going to network firewall. This is our second demo. So here, this is my machine, and this is my machine, and I just one prompt. Let's see if I will that in my notepad. Okay. So what is our compute instances? So this is my Linux IP 192.168.3.49. I have created the ICMP rule to be pingable from my Windows machine. Let's see whether I can able to ping that machine. 192.168.3.49. Okay. Here comes ping 192.168.3.49. It will not copy paste. 3.49, and it should be pingable from my Windows machine. That is from one subnet to another subnet. So I'll just enter it, and yes, you can see it is easily pingable, and ICMP is working fine. That means that it is working fine. The rule which we have created, it is working fine. Okay, let us see what is the IP of this machine. So this machine IP is 192.168.2.13, and it is going to 192.168.3.49. that is from one subnet to another subnet. Okay, now whether it is going through OCI Network Firewall or not, we are going to trace now. Trace RT 192.168.3.49, and let us see the next hop. So you can easily see the next hop while going from one subnet to another. It is taking my network firewall 192.168.1.180. So it is clear that it is going to network firewall and my ICMP is working fine. Now for 3.subnet, the Windows machine, that is private Windows hub 3.42, I have not created ICMP role. I have created only RDP. So ICMP, that is ping, should not work for 3.42, but yes, RDP should work. Let us see that. So here 3.42, right? So ping 192.168.3.42, and it says destination network unreachable, destination network unreachable, and all the packets are lost. ICMP is not done. So, and trace route will also not be done. But yes, you can see the next hop as network firewall is the trace route. But yes, full trace route will not be done because ICMP I have not enabled for 3.42. So, but yes, you can still see the next hop is the firewall, whether it is going to firewall or not. And you can see that it is going to a firewall, but trace is not completed for 192.168.3.42. Over here, you cannot see over here because ICMP is not enabled for it. Okay, so what is enabled? What I have enabled in the policy, I have enabled RDP for it. So I'll just do an MSTSC over here and see if I'm able to do a RDP to it. 192.168.3.42, and let us see if I can do an RDP. Yes, I'm able to do RDP. I'm closing it because this is just to showcase that yes, our policy rules are working well. So this is our second demo, which says from subnet to subnet communication, and I'll show you again the PPT over here. Okay, so this is from subnet to subnet communication. From one subnet to another subnet, it should go through the firewall subnet. We have seen that by allowing ICMP for links, but not Windows, only RDP to Windows, but not ICMP. We have checked that from the demo itself. It is going to the OCI Network Firewall. We have checked in the trace route. It can be checked in the logs. In the logs, in the logging section, you will see each and every traffic which is going in and out of your OCI Network Firewall from the resources on OCI, or from the resources which are coming from outside OCI also. Now comes our third demo and final demo over here. Third use case, you can say. So in this use case, DRG comes into the picture. That is dynamic routing gateway. Their internet gateway was there. In the second use case, it was subnet to subnet communication. It was within the VCN. Okay. Here DRG comes into the picture. So here, yes. So this is my customer data center. This is my customer VCN address range, and yes, just to be sure, over here there should not be any overlapping address ranges within OCI or for on-premises which is communicating with OCI, because that is not supported. Okay, so this is the address range on customer's data center which wants to communicate with OCI region over here, OCI VCN, and it will be having a DRG. DRG will be having a DRG route table and a VCN route table also. I'll be showing you those route tables. Okay, and that route table will be saying that if the traffic is destined for 10.10.0/24, it will go for my 10.10.1.10. That is my firewall over here. And to come over here, it will be having a backend route to go from a dynamic routing gateway to my IPsec tunnel, and this I'll be showing. So I don't have an IPsec tunnel because it needs on-premises connectivity or any third-party connectivity. So I'll be showing you this kind of architecture for our VCN to VCN communication over dynamic routing gateway. That is my third demo which I was talking about. So customers for which I have deployed OCI Network Firewall, they actually go for hub and spoke models like this in our network visualizer. Like here, you can see a firewall network where you are having your OCI Network Firewall. Their resources will be into the spoke VCN, which is communicating over a common DRG. This is the name which I have given, that is common DRG, and the work of this DRG is to create DRG connects to these VCNs in such a way that when the traffic from on-premises or from this one network to another network, subnets wants to communicate with each other. If the subnets within the networks, within the same network wants to communicate with each other, they should go through the network firewall for the monitoring purposes. And if it is going for on-premises, from DRG to IPsec or virtual circuit connections, they should go through my network firewall. For that, yes, this is the most common use case, and that is used in the general scenarios also. So I will be showing you in this demo when the traffic from my spoke VCN wants to communicate to my machines in my firewall network. It will go through the dynamic routing gateway connection, and through dynamic routing gateway connection, it will go to my OCI Network Firewall and to the destination server. Same happens when the machines from my firewall network wants to communicate the machines into my spoke VCN. It will go to my firewall first, then firewall will send it to the common DRG, that is dynamic routing gateway. Dynamic routing gateway will send it to the destination. How this routing looks like, I'll show you over here in my network firewall, virtual cloud network. So I'm having two virtual cloud networks over here, and what I'm going to do is show you is I'm going to communicate from 192.168.0.0/16 to my other virtual cloud network, that's my spoke VCN. In this demo case, there is 172.16.0.0/16, and it should go and monitor through my OCI network firewall. So on my firewall network, suppose this is my hub machine, which I have already logged in. We have done some tests with it, and it is in my 192.168.2.0/24. Okay, and I want to communicate with this machine through my Windows Linux spoke, that is 172.16.1.193. I will open Notepad. I will open Notepad over here, and I will just take a note of this IP. Okay. So this is my IP 172.16.1.193. 16.1.193. Okay. So what I'm going to do is, this is my Windows hub machine 192.168.2.30, and I am trying to communicate with Linux spoke one, that is 172.16.1.193. Again, I've created an ICMP role for that is ping. I'm able to communicate with it on ping. But the thing is that the traffic which is going from one VCN subnet to another VCN subnet, it should be traveling through my OCI network firewall. So what policy I have created for it? What routing I have created for it, I will tell you after my demo. But yes, what policy I have created for it. So here, okay, we are running out of time. So here in the policy section, you can see here for my spoke. Okay, this is the spoke policy which I have created. It says if the source is hub Windows machine or private Windows hub machine, and the destination is private Linux spoke machine, then allow ICMP for it. So just to reiterate again over here, if you will not allow anything, if you will not create any policy for the traffic hitting on your firewall, by default everything is denied. By default everything is denied. Okay, you need to, if you want to allow something, it needs to be created by a policy over here. So I have created a policy for ICMP in my for my destination is private Linux spoke one, and source as hub Windows machine or private Windows hub machine. I have shown you from hub Windows machine, we can still take a RDP into private Windows hub by the rule which we have created. And for my RDP Windows machine in my spoke, I have created for my hub Windows machine or private Windows hub, destination as the private Windows spoke, allow RDP. So I take the compute RDP also over here. I compute RDP is this one, this guy, 172.16.2.148. 172.16.2.148. Now you can see it, right? These two machines in the spoke, still they are in different subnets. So they are different. One is in 2.0, 1.0. They'll still be able to communicate with any of the hub subnets 192.168.2 dot or 192.168.3 dot through our OCI Network Firewall. So we have logged into 192.168.3.48.2. We'll try to ping this machine 172.16.1.193 and it should be pingable. Let me just say that. Ping 172.16.1.193. Click on that. Yes, it is pingable. You can see that it is pingable. But I can only do a ping. I cannot do SSH onto it because only ICMP is allowed. ICMP 0 equal replayability for ping. Now here I will do a trace route. So first hop should be network firewall. When the traffic is going from one subnet to another subnet over dynamic routing gateway from one VCN to another VCN, first hop from here should be the network firewall because this traffic is going for the network firewall VCN. Network firewall, from network firewall it should be going to 140 IP or some 140 some IP, that will be our dynamic routing gateway IP, and then it should forward it to the other subnet. Let us see whether we can locate over here 172.16.1.193, and when I go to it you can see it very clearly. So the first hop is network firewall. Second hop is my dynamic routing gateway 140 IP, and the third hop is my destination. So instead, I'm able to do it. Ping to this machine. Now we'll check. We have not allowed ICMP for my Windows machine in this book, so I'll just say ping. It should not be pingable. Ping 172.16.2.48 and put it over here, and says destination network unreachable. But at the same time, when I try to create a MSTSC connection through it for my RDP, which I have allowed for 172.16.2.148, it is allowable. Yes, I am not going to take the RDP, but yes, you can still see RDP is allowed over here. So these are my 3 demos. Now I want to introduce some asset which we have created onto my conference page to see how this routing looks like when it comes to these 3 use cases. So I'll be showing you the PPT for that too. Before going to that, this is my IP. This is my IP 122.172.85.42, where you can see the logs on OCI Network Firewall. So in here in Network Firewall, when you click on the Network Firewall, you will see the logs. You can create your own matrix. Again, I'm saying you can create your own matrix, then logs and log matrix. So I'll be going somewhat fast over here. So here you can see the logs. You can enable your threat logs for IDS, IPS. You can enable your traffic log, which is coming for your for your resources on OCI. So here, when I click on the traffic log over here, because I'm not enabled IDS and IPS in the security rules, so but you can still do that. So in the traffic log, I click on this logging section, and I have already just to show you how you can see into the log search. I have filtered the log for my IP 122.172.85.42. That is this one, and I can see the traffic which is coming onto the logging section over here. And let me just click on one of the log over here. It is very detailed log, which you can see over here. The source IP is my IP, that is my machine IP, client IP, my destination IP. You can see somewhere over here. This is my Windows IP. My destination port is 3389. Which rule it is, which security rule it is taking into place? Allow-IDP. Like this, you can see all the logs for your east-west traffic, for your north-south traffic, which is coming the internet gateway, for your north-south traffic, which is coming over dynamic routing gateway. Yes, the question comes whether the traffic that is going over my service gateway or net gateway can be monitored through my network firewall. Then the answer is yes to that. So these are the demos which are okay. One thing which I'm missing over here is my decryption profile and decryption rule. So the decryption profile which I have created is for SSL forward proxy. There are 2 types of decryption profile which you can create. One is for the inbound inspection traffic, and one is for the outbound inspection traffic, that is creating SSL forward proxy for the traffic which is going out of your OCI resources. So what I've done onto that is, in policies, in my decryption rule, I have created the traffic which is going out this SSL forward proxy from my hub Linux machine to any IP address. Go check the map secret which I have created into the OCI vault. OCI vault. So OCI vault is also integrated with our network firewall. You need to create a map secret over here and create a decryption profile with that map secret. So there is a separate tutorial which is coming up from us on how to create the map secret, how to create a decryption profile. It is a step-by-step process, and it is not a long process. But yes, you can go through that particular tutorial and create your map secrets onto OCI vaults. Create your own decryption profile. This decryption profile I have created for my SSL forward proxy, and what it does is, when the traffic is going from my hub Linux machine to any IP address or over to the internet or anywhere, east-west also, it will check. For HTTPS, it will decrypt the traffic. It will check the traffic whether it is legitimate or not, and then it will send it to the destination. So this decryption rule is there. After this decryption rule, I have created some lists over here. And in my URL list, I have allowed the URLs for star.oracle.com or www.facebook.com as a social media network. And star.oracle.com. So I want my users to access only star.oracle.com or www.facebook.com if they are going through my Linux machine. This you can create for any of the resources on OCI VCN which you are having. So here, and by default everything is denied, but yes, if you want to deny it for some machines and for not some machines, you need to create the denied list over here. So I've already created a decryption profile. It will decrypt the traffic, then it will go to the security rules over here. It will check what are the rules which I have created for my allow, and it says what are the rules. Let us see. It says source is any IP address. You can create source as your hub Linux machine over here. Destination any IP address. If it is destined for TCP 8TF443, allow URL. In my allow URL, only oracle.com and facebook.com are allowed. Let us see. So I have already logged into my Linux machine. Let us just see whether it is still. Okay, this is my Linux machine. Let us just see what is my IP. So this is my IP over here, 192.168.2.247. If I try to do a wget HTTPS to my www.oracle.com, which I have allowed, okay, so it should be allowed. It should be connected, and you can see HTTP 200 response, and it is showing connected. But if I try any other URL than oracle.com, facebook.com, say wget HTTPS, I'll go for google.com over here, google.com. So what it says it is still trying to connect. It is retrying. It is not connecting to that particular server which is running google.com. So this is the last thing which I wanted to showcase over here.